The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
Alright, so I'm going to work through problem number 17 for Physics 2020 Midterm Exam 1, year 2010. And in this particular problem it says, a person in an airplane traveling at 50 meters per second wants to drop a package into the stadium located at ground level. The airplane is 300 meters above the ground. How many seconds before the airplane is directly over the stadium should the package be dropped? Alright, so this is an illustration of the problem statement, and okay, so we have an airplane that is 300 meters above the ground, which I have detailed here, and we have the stadium, and this airplane is initially traveling at 50 meters per second. So we know that the initial velocity is in the x direction, which we can just consider that the entire initial velocity is equal to 50 meters per second. Since it's only traveling in the x direction, let's actually set up our coordinate system where we have, this is the positive x and this is the positive y. Okay, so since it's only traveling in the direction x direction, that implies that the velocity, initial velocity in the y direction, then is 0. Okay, and so given this information, how are we going to solve the problem? Well, this is not a trick question, but if you do know some fundamental things, it's a lot easier to solve this problem. Knowing that that gravity only acts on an object in the y direction is really helpful. Why is that helpful? Because let's say that we drop a package from this airplane, all right, at 50 meters per second. This is the red line is the trajectory that the object is going to follow before it hits the stadium, the ground in the stadium. So basically the gravity is actually going to only act in the y direction on the object. So that means that the velocity in the x direction is going to be constant throughout. So as this package is falling, it's still traveling 50 meters per second in the x direction, and but there is going to be some acceleration on the object in the y direction, which is going to cause this initial velocity in the y direction to increase from 0 to some other velocity. Okay, so what does that mean? That means that basically the time that an object takes to fall from this 300 meter height to the ground here is the same time that it's going to take to hit this point in the stadium, because gravity is only acting in the y direction, so that the distance that it travels from here to here is the same distance that it travels from here to there. Okay, so basically all we need to do is find out how much time it's going to take for this object to fall to the ground if we dropped it straight down. Alright, so if you look on your formula sheet, okay, you have equations for projectile motion. You can look at the equations in the y direction, and in that set of equations you will find an equation that looks like this. Okay, and so we know our y value. Our y is going to be, this is our final y, so that's where the object is going to hit the ground, so that's going to be 0. Our initial y the object starts at 300 meters, the initial velocity, okay, we know that the initial velocity in the x direction is 50 meters per second. But as I said earlier, we're basically going to simplify this problem by saying, okay, we have an object, and we're just going to drop it straight down because we know that that's going to be the same time it takes for it to reach the ground at the stadium here. So we don't really care about the velocity in the x direction. We just care about the velocity in the y direction. And the initial velocity in the y direction is starting from rest is 0. Okay? So we know that the initial velocity in the y direction is 0. Okay? And so we can actually just rewrite this as the initial velocity in the y direction. The same thing is we have the sine of theta in the y direction. Okay? So the initial angle, if we're just going to drop it, remember theta is the angle that it makes with the horizontal, and if we're going to drop it straight down, then the horizontal is here. We're traversing an angle that's basically minus pi over 2. So we have the initial theta is equal to minus pi over 2. Alright? And we want to find the time, so that's important that we have the time in this equation, and indeed we do. And so this is the actual equation that we want to use to solve the problem. Alright, so let's simplify this equation. Let's rearrange the equation this way, where we bring the initial y to the left side of the equation. And we know that the initial velocity is 0, so that makes this whole term go to 0. So we're just left with minus 1/2 times the gravity times the time squared. Alright? Now, we want to solve this equation for t. Okay? And so, basically when you solve this equation for t, since we have a t squared here, t is actually going to be plus or minus the square root of minus 2, and the minus 2 comes from this 1/2 here. When you actually multiply by the reciprocal, you get a minus 2. And you're going to get delta y. So we know that delta y is y minus y sub 0. So that's delta y. And we know that the initial y, or the final y, is 0, and the initial y is 300. So this term is going to be negative. It's going to have a negative value. So that's going to be negative 300 meters. And we know gravity is going to be 9.8 meters per second squared. Okay? So we see that the meters cancel out. We have a second squared in the denominator. When you divide it out, it will become in the numerator. And since we're taking the square root, the square term is going to go away. So we do our calculation, and what do we get? We get 7.82 seconds. And that is our answer. So this problem was not that difficult if you understood that the time it takes an object to fall to the ground is independent of how fast it's traveling in the y direction. The only thing that matters is the height from which you drop an object. Doesn't matter if it's moving left or right in the horizontal direction. Only thing that matters is the height. And the time it takes for it to hit the ground is going to be the same time it takes for it to hit the ground at a particular height if it's moving with an initial velocity in an x direction. So that's the critical key to solving this problem. So as you can see, that helped us to simplify our equation greatly, so that we could just get an equation for solve this equation for t, and then indeed we got the answer to be 7.82 seconds.
The Teaching Center, UF's Learning Support Center. www.teachingcenter.ufl.edu.